Before we can talk about Gibbs free energy, let's talk about spontaneous reaction. Spontaneous means the reaction takes place on its own without external push, but doesn't mean it's fast. It could be a slow reaction that is also spontaneous. Let's look at some spontaneous reaction. The first one is combustion, the act of burning. Once you initiate it, it goes to completion. And when we measure delta H, we see it's exothermic and its negative value. Another one is rusting. We don't like rusting, but iron in presence of oxygen and humidity rust. And this is also exothermic reaction. So now the question is, are only exothermic reactions spontaneous? Let's look at endothermic reaction that is spontaneous. Ice melting. In the process of melting, you absorb heat from the environment in order to become liquid water, and the amount is positive 6.9, which is endo. So what is the other driving force? If nature likes exothermic reaction, in a case of ice melting, which is endo, what else causes this reaction to be spontaneous? The second driving force is entropy, which is a measure of disorderness or randomness, and it has units of joules per Kelvin per mole. So if you change the state, if you go from solid to liquid, your delta S increases, your randomness or disorderness increases. And if you turn into gas, it further becomes more positive or increases. So nature likes disorderness, nature likes exothermic reaction. Now Gibbs put these two quantities into one equation. But before we look at this equation in detail, I drew a diagram of reactant becoming product. Delta G is this quantity, and by convention, if you're up here, you have tendency to go downhill to release your potential energy. This is the case that delta G is less than 0. So when you calculate it and it's negative, that's the time we are going to call it spontaneous. Now, if it happens that the reactants are sitting here, this is at equilibrium, where delta G is equal to 0. You're not going anywhere, and you need some external push, such as temperature. So this is equilibrium, that nothing is happening. Now, if you are here and you want to go uphill, that's when delta G is bigger than 0, and you are non-spontaneous. This is not also taking place unless you push it forward with temperature. So delta G negative is when the reaction is spontaneous. Now Gibbs put quantities of enthalpy and entropy together in this fashion. Delta G, if you want it to be spontaneous, we want the reaction to be exothermic, and we want it to be more disorder. And T is your absolute temperature in Kelvin. So this is Gibbs free energy in terms of equation, which has two driving forces of enthalpy and entropy in it. Now let's look at some possible cases. The case that delta G is less than 0, exo, and the case that you are becoming disordered, this is the case that you are always spontaneous. Why? Because this is negative quantity and this is a positive quantity. And when you had negative, minus times positive is also negative, this turns to make delta G negative. So this is spontaneous at all temperature. This is the base case scenario, exothermic and disordered. Let's look at a case that is never spontaneous. If you are endo, and if you become ordered, you're not moving, you rather become one. This is the case that you are positive, and this is negative. Negative times negative is positive, plus a positive makes a quantity which is positive. So this is never spontaneous, non-spon at all temperature. So this is a reaction that you cannot make it spontaneous. Now there are two other possibilities. Let's look at a case that you are endo and disorder. Remember, this was the case that ice was turning into water. Delta H is bigger than 0, and delta S is also bigger than 0. So when does it take place? When the temperature is rather warm or hot. Temperature equal hot. So this is a case that you are here, and if you are positive, and if this is also positive, in order to get a negative value, the temperature has to be really high. So this is spontaneous at high temperature. This is when you play with the variable temperature in order to make it spontaneous. If you look at the reverse, if water wants to solidify into ice, now this is exothermic, so you are here. This is when delta H is less than 0. And in order for that to take place, also you're becoming ordered, which nature doesn't like. So exo, it likes, ordered, it doesn't like. In order for that to happen, you should make the temperature cool or below 0 degrees Celsius. So this is the case that you are exo, and you are also ordered, which is negative. Negative times negative is positive. In order for this quantity to be bigger than this, the temperature has to, negative times negative is positive. In order for this quantity to be smaller than this, the temperature has to go down. So this is spontaneous at low temperature. So these are your 4 possibilities for sake of multiple choice or making a judgment.